5th, 6th, 7th, 8th, 9th. Okay, no, you're lying over that one. So our talk that we had scheduled, unfortunately, cannot happen for a handful of reasons, some of which involve the lawyers. In lieu of that, what we're going to be doing is we're going to be doing some lightning talks. Anyone that has something to say of merit, or hopefully of merit, or at least if you think it's of merit, I'll ask that you line up over here, and you're given 5 minutes to say what it is that you have to say. So if you've got something productive to add, please go ahead and start queuing up over here. We've already got a couple of people lined up. And actually, to kick this off, we're actually going to have Johnny come up here and initiate the 5-minute session with, I think he's got a little bit of something to say on his own. So.
I got a lot to say, I just can't say it all.
So in lieu of the talk that Johnny was supposed to give, Johnny's going to give you 5 minutes of his bile and ranting instead of that. So Johnny Cash, everyone.
All right, so I'll try not to yell into the mic. You can imagine I'm pretty pissed. So basically, instead of giving my talk, I'm going to try to give you guys the reason why I'm not giving my talk. Not nearly as cool. So I'm going to read my little thing that doesn't get me screwed and hope to walk out of here without any people stopping me. So most of you know that we were supposed to be talking about exactly what happened with us regarding Apple and the Black Hat talk we gave. And most of you probably also saw that SecureWorks told a few reporters that they were not going to let Dave give this talk. I cannot give this about Dave. A lot of people think that Dave just flaked out and missed his flight or something, which I can forgive them for thinking. He has flaked out and missed talks, but he usually makes them. That's not what happened this time. Dave very much wanted to be here. The fact that SecureWorks/Apple managed to compel him not to means that they had something very compelling to stop him. I'm not supposed to talk about what that is. Mac bloggers everywhere will view this as some sort of victory. There are already people writing that SecureWorks stopped Dave because we were going to say that it was all fake. Right. We reserved an entire speaking slot to tell people that we were just, screwing with them. And people believe these people. It's insane. So let's recap this a little bit. We gave a talk saying that device drivers had lots of bugs. We demo one bug in Apple. A few days later, when Apple starts flaking on a patch, we tell them we are going to give a live demo of it at ToorCon, so it would be a good idea to get it patched before that. Apple says that it doesn't exist, and publicly Apple says it doesn't exist, and we didn't talk to them about it. A few weeks later, 1 week before ToorCon, they patch it and say we had nothing to do with it. 1 day before the talk, SecureWorks and Apple get together and manage to stop Dave from coming. They also issue the following cutesy press release. SecureWorks and Apple are working together in conjunction with the CERT Coordination Center on any reported security issues. We will not make any additional public statements regarding work underway until both companies agree, along with CERT, appropriate. That's funny. I thought there was no bug, and I thought SecureWorks provided no useful information to Apple. Here's Lynn Fox on the record with George. Did SecureWorks ever disclose packet captures as a malicious payload to trigger said vulnerabilities? Lynn Fox. No, packet captures were promised repeatedly, but never delivered. Did SecureWorks ever provide driver disassemblies pertaining to said Wi-Fi vulnerabilities? Lynn Fox. No, while SecureWorks did provide a driver disassembly, it did not indicate a Wi-Fi vulnerability in any Apple product. Did SecureWorks ever provide crash dumps pertaining to said Wi-Fi vulnerabilities? No. While we received crash dumps from SecureWorks, they didn't have anything to do with Mac OS X or any other Apple products. Did SecureWorks ever point to the location of the vulnerable code of said Wi-Fi vulnerability? No. Do any of the current patches released by Apple match any of the characteristics of the information provided by SecureWorks? No. So Lynn Fox has essentially said that we didn't tell them anything, we gave them no packet captures, and we gave them crash dumps that don't relate to Apple. If we had given them nothing except crash dumps from like a Windows box, do you think they would have audited the hell out of their wireless drivers? Like, does that make it, like, they would just say, piss off, quit giving us Windows crash dumps and get out of here, not audit the hell out of their shit. So anyway, if SecureWorks provided them with virtually nothing useful, Then what the hell could they have to coordinate with CERT? And why did they wait till one day before Turcon to decide this? People have called me and Dave a lot of things. First, we were totally frauds that faked everything. After our patch was out, we were mostly upgraded from total frauds to unprofessional. Let's talk about unprofessional. Apple and SecureWorks had 2 months to stop Dave and I from giving this talk. Why wait till the day before? Neither Dave or I found out about this till yesterday morning. How is that for professional? And that's all I got.
Oh, okay. Go ahead and step up. Okay.
Hi, I'm Strom Carlson. So you guys have a choice. You want the short version of the Hacking Kinkos talk, or do you want the version of the Hacking the Cryptographic Community for Fun talk? Okay, how many for Kinkos? Okay, how many for cryptographic community hacking? Okay. 3. 3. 3. Oh, someone gave me a Kinkos card. Yeah. Well, okay, I guess I'll do the short version of both. So, quick rundown of those for those of you who didn't see the cryptographic community talk. Basically, there was something a bunch of friends and I did over the summer called Project Evil. How many of you saw the VoIP number stations on Slashdot? Yeah, like the guy who won my contest on some guy in the back. Anyway, what we did was we made a whole bunch of number stations, and what number stations are, for those of you who don't know, are shortwave radio stations that you tune into, and they're just like sequences of random numbers being read back by recordings. So everyone assumes that they're encrypted messages for spies out in the field. And so what we did was we decided, let's do VoIP number stations, and we proved that you can do number stations cheaply and inexpensively over the phone and get people to relay your message for you, so you obscure the transmission vector. And so we encrypted all sorts of, silly things like hi to you, 3-letter agencies, lol, and fun things like that. And so what's cool about it is, the way we got the voices for the number stations, we just had a recording that sounded like, 1, 2, 7, 9, 3, 1, 2, 7, 9, 3. And the way we got those recordings was I called up random people off Craigslist who were advertising in the erotic services category. And as soon as they answer, you just say 3, 3, 3, and then they'll go 3 what? Or 4? Or 5 who? And so you take the recordings of them responding to you and you just patch them all together, and you kind of get the audio equivalent of, those ransom notes where all the letters are taken out of different magazines. So we did that, and so no one could identify the voices, because I had no clue who they were, and no one knew where the hell the numbers were coming from. And so this made Slashdot, this made Off the Hook. Off the Hook, in fact, ripped us off and used our number station recordings for Hope. So, and no one knew who the hell it was until we gave our talk at DEF CON and said, yeah, it was us. So, and the whole cryptographic community was up in arms trying to figure out what the hell this was. So that's the short version of that one. Short version of talk number 2. How many of you have one of these in your wallet? It's a Kinkos card. You? Okay, and no one else has been to Kinkos recently? You? Okay. So anyway, these are really hackable. These cards, in a nutshell, are a 256-byte memory chip with a 3-byte security code protecting the memory. And all you need to do in order to figure out that code is get yourself a logic analyzer, solder some wires to the chip, and plug that into your logic analyzer, take the whole affair to Kinkos, start reading on your logic analyzer, stick this thing into the machine, and finish your data capture, go home, start analyzing it bit by bit. You look at the data sheet for this card, and you see there's a specific sequence of commands that need to be issued to the card. So you look for that sequence of commands in your data dump, and right there in clear text is the security code to alter data on these chips. So you get that security code, and all of a sudden you take your card that has $1 or 2 cents on it or whatever, and you can just change, say, $100, whatever. And so the proof of concept for this was I altered a card, and I went to the kiosk, and I stuck it, and I took a photo, and the photo says, your balance is $313.37. And so I discovered this in February and notified Kinkos, and they never heard anything back from them. We went public with it like a month later. And now it's almost October, and they still haven't patched it at all. So, still the same problem. And so, yeah, I'm not going to tell you. So in conclusion, dead hookers.
We've already had a couple of people express that they wanted to talk on something. So again, if you have something you want to say for about 5 minutes, please queue up over here. When you come up to the mic, introduce yourself by your handle or your name or whatever it is you want to go by. And you've got 5 minutes. Come on up.
Greetings. Can I use the LCD projector by any chance? It'd be very cool. Ah, excellent. Okay,
Yeah.
Yep, it is. Okay, so I've got 2 stenography tools that I'd like to show if I can. Oh, I just got it. Okay. Okay, one's text stenography that I wrote in the last 48 hours, and the other is picture stenography. Ah, excellent. I cannot see it here. So, okay. Ah, okay. So the idea for stenography of images is that flip random bits, the least significant bits of an image, and it doesn't really change that much, and someone looking at it wouldn't know the difference between a digital camera image or a stegged digital camera image, because digital cameras flip bits randomly. Okay, so that's what my program does, and I use cryptography, of course. See if it works. I haven't tested on this machine. Source/rubber spoon. Hooray! Okay, so I got a GUI interface here, just for no reason at all. GTK, and so you click load image, you grab your file, which is IM. A little nervous. There's problems with this, and that's the plausible deniability. The idea is that if you brute force every key, you'll eventually have one that looks like all your base are belong to us, and the rest don't look like anything. So there's a lot of interesting ideas to fix that. Okay, and so then you type your message. I should probably do something readable like la yak or something. And then you go upload, and you put in a passphrase like test, and it saves it to the disk instead of uploading it to a server. But the idea is that you'd upload these to a server, and then someone would download them from the server, or you could do instant messaging. groups. A lot of good ideas are out there. Hopefully, it has created a file called something or another. Yeah. Okay, so so the obvious, oh, great. Okay, I give up. So I can show you something even cooler, which is my TextSteg program that actually works. If we have Python, and it's tsteg a. Does that say what it's supposed to say? Okay, so you take a dictionary of words and you do some type of thing where you can transcode letter whatever to a large set of words. And for a test, I've decided to, good. Okay, so you get your secret, and then you type in your hex key, hopefully. And of course, it was written today, so that's, so 1, 2, 3, 4 is a good key. Uh-oh. Oh, yeah, because there can't be spaces. Okay. It's a very, very raw thing. Okay, so 1, 2, 3, 4 is a good key. Okay, and it comes out with something that looks like spam. Doesn't that look exactly like spam? What it is random words, right? Except that certain words are keyed to BL. And you can actually, the decode function comes out with BL, H, and then an extra N because I screwed up the code. And there you go. You can actually encrypt anything. And it looks exactly like spam, except that there's a problem in that if you brute force every key, you'll eventually find 1, 2, 3, 4 key that actually decodes to blah, and oh, we've answered it. And so that's a problem with steganography that has to be solved. Maybe massive, massive keys will solve the problem, or some exotic system. Questions? Ideas?
What's different about your tool?
Nothing at all. This TextSteg is as simple as you can get. It's simple steg. If someone were to create a TextSteg program, they'd probably write it in C, but it would do pretty much like this, maybe a bit better. Yep. I'm just implementing it. Implementing the good theories that are out there. Okay. If there's any, I'd like to plug a Neg9 group, which we meet in Seattle and Chico and everywhere. URL is neg9.org. Thanks.
Cool. I just love the fact that people are willing to come up here to share what they're working on, because that's what ToorCon's all about, is sharing your ideas and sharing your work. So it's nice to actually have a little bit of a venue for people to do that in here rather than the hallway where it normally happens. But we've got, you ready? We've got a few more people queued up. Again, if there's anything you want to talk about for 5 minutes, please go ahead and line up on the side of the stage and introduce yourself when you're up here, and you've got your 5 minutes of fame.
So I figured, 5 minutes, why not? I'm DJ, I'm over at UCSD, and so I briefly wanted to talk about hashing algorithms, because lately we've come to a realization that they all suck. MD5, of course, is increasingly broken in the last few years. SHA-1 looks like it's going. SHA-0 went a while back. And really, it's going closer and closer, and Kaminsky, who's probably here somewhere and speaking at some point, has been taking Boeing web pages and Lockheed web pages and saying, look, they hash the same, and, they're exactly the same thing. And we can totally exploit these minuscule vulnerabilities in hashing algorithms where as soon as you have one collision, you're screwed. So the root of this problem really is in the Merkle-Damgard construction of hashing, and what that basically means is you take a stream and you break it down into blocks. And all of this attack is relying on one collision. You can take that block, you can determine that block as your condition code, and then output a completely different sequence that can hash to the exact same thing. So really, the problem here is not in either of these hashing algorithms, but in the construction blocks where we're taking stream algorithms and them blocks. Now, if we do that differently, we can actually get a different approach. So, for example, if you take a standard algorithm that's badly broken, like MD5, and you break your data up into blocks, and that's how you get your hash eventually. Now, if you move everything over by a half a block and rehash it, and combine those hashes, you can get something completely different. You can also do some reordering. You can also do some masking. You XOR off based on the location of your block against the total block count. And then you mask that. And now not only do your collisions have to be special purpose for the data that you're actually using, but they don't have the same problem where Boeing's web page and Lockheed's web page encrypt to exactly the same thing anymore, because you actually have to hash, or you have to collide on two different data sets, and you have to collide on that boundary where you've moved and relocated elements. So really, I just wanted to come up here to say that anyone who does plan on making a hashing algorithm in the next few years, one of the things that you're probably going to see out of the new generation of algorithms is that they won't just be block-based, and they won't just split it up into simple blocks like you've been seeing for all of the hashing algorithms pretty much in existence so far, including, I believe, the newer Whirlpool and other types of things. Yeah. Yeah, two different hashes is also a solution that's been done, and it's a good solution. But there's some skepticism among cryptographers because you actually use the different hashing as vectors to attack the other one. It's tricky, and honestly, I don't know how they do it, but it can be done. And so, two different hashing algorithms isn't honestly the best. It would be nice to actually have an algorithm that worked, and that as soon as you gained a collision, it wouldn't immediately deteriorate into something that's unusable. And really, the emphasis on that should be at the actual level where we split the data into blocks. There's a question back there. Right. Yeah, no, and part of you can go on Schneider's blog, and he has links to discussion notes, actually. And part of the discussion is that they're going to have to look at a different way of thinking about hashing algorithms. And, that is about the time to do it. And the block function is an important place to look at. Yeah. Right. But before I end, there's one place where I want to point out where this doesn't work. excuse me, where Merkle-Damgard is why it was done and why we did it this way, and what the new generation of hashing algorithms are probably going to have problems with. And that is with streams that you don't have a bounded length for. If you don't have a bounded length, we have to use something like this. And we've always designed algorithms with the expectation that they're going to be used on streams, and we have to be able to use them on streams. If we throw that away, we can gain a lot of security simply by knowing the total block size. And then we can do some tricky things to actually put that data embedded in, mask it, and basically defeat those attacks, which is why I think hopefully we will be seeing something better soon.
Hi, my name is Ivan Krstic. How many of you guys have heard of the One Laptop Per Child project, also known as the $100 laptop? Excellent. So what you probably haven't heard is that we're actually putting an enormous amount of work into security engineering on these machines. And I'll tell you why I don't sleep at night. I don't sleep at night because we're building the largest monoculture in the history of the computing industry. So if we succeed, we'll have built 1 billion laptops that actually run largely identical software, largely identical OS images, and obviously this is scary. So it's also problematic because of the target users who many of them have never seen computers before. Many of them are young kids who you can't at all expect to have any idea of what constitutes reasonable behavior on the internet and what computer security means. And we're actually doing a couple of radical things. So all of our machines will be running IPv6 by default. We're building up all the network infrastructure to use IPv6. Tons of security problems with IPv6. Really, the situation hasn't improved at all with IPv4. And there are a bunch of other things that are just sort of very scary when you start thinking about it. So one of the key goals that we have is to make these machines very hackable by the kids themselves. Hackable in the sense that we believe that there's actually a lot of value to being able to take your machine and rip it apart and see how it works and change it and put it back together. But when you're building machines that are explicitly designed to be very hackable, really this is in pretty stark contrast to having the machines be secure. And there are a couple of just things that I want to outline as brief ideas of what we have to deal with. One of the things that we're really insisting on is making collaboration more central to the user experience on these machines. So right now, if you're writing a text document and I tell you, well, grab one of your friends and collaborate with him on this text document, you really can't do this. The only way to do it is specialized text editor that does collaboration built in. And even then, it's going to be using some different form of figuring out who you're talking to than, for instance, being able to utilize your AIM buddy list or something of the sort. So we decided that this is really a bad approach, and we're actually making collaboration a system service in the sense that any application on the machine can basically say, I have these collaborative abilities and use the same API that the system exposes to do collaboration. So one example of one follow-up to this is that if I have a certain application and I want to collaborate with the person that's trying to take a picture of me in the front row here, I can, I can invite him using the system to collaborate with me. But what if he doesn't have the application? Well, ideally, what would happen is transparently he would receive the application and his machine would run it and we'd collaborate. But let me say that again. Transparently, he would receive and his machine would run it, and we would collaborate. If this isn't bloody scary, so it's scary. And there are a couple of other sort of interesting things that we're doing, right? One part of having machines be hackable is actually having it not be scary to screw up. And the way that you don't make machines scary to screw up is you make sure that recovery is trivial and isn't any kind of an intimidating process. We can actually restore machines from USB sticks, from a server, or from the mesh network. The networking we're doing is largely mesh-based. 802.11s, it's a new emerging standard. And no one has actually studied what security means when you're dealing with really large meshes. There's some work that came out of the sensor network community, but it's not directly applicable to us. Packets will be forwarded almost always by some of your mesh peers. So if you're not some kind of authentication, etc., you really have no guarantees on what's actually happening. So anyway, long story short, this is actually the hardest thing that I've ever worked on, is the security for these machines. And what I want from you guys is to either find me around the conference or mail me at ivan@laptop.org, that's IVAN@laptop.org, and tell me, yes, I want to help you try and break these machines. Because very soon now we'll be releasing a series of security specs for the machines, and I want the best and the brightest to look at them and figure out how we can actually break these machines before there's a billion of them out in the field. Thank you. Questions? No questions? Wow, I scared you guys shitless. All right, good. Thanks.
Hi, my name is Jason. I'm the co-author of YCrawl, which demoed at 3 p.m. over in here, at the other room. Aaron Peterson's talk. I'm just up here to pimp HT, which is a disassembler that I really like and no one knows about. I wish more of you did because it's a wonderful tool. And the projector doesn't want to show the console. Let me make this a little bit bigger. Hey, you guys can see that, right? All right. So the other day, I was trying to open up a command prompt on a machine. There was a security policy defined on the Windows machine that was preventing me from opening it. So I thought to myself, well, why is it not allowing me to run a command prompt? And it turns out that the code to do that is actually in cmd.exe. But I didn't have IDA on the machine. I did have internet access, and so what I did was I went to the HTE site on SourceForge, and I got a copy of it. So I went and opened up command.exe. This is the tool, HTE. It's a single executable. It's about 700K. It runs on Windows, Linux, OS 10. It's a fantastic tool. Lots of good source code in there to steal. And I said to myself, well, there's probably a registry entry somewhere in here that's being read to figure out what the security policy is. And so I looked around here using a feature the tool has to figure out what functions it calls inside of Windows. And I don't see it now, but another way that you can use this tool to figure out what the program is doing is to go to the disassembly view and tell it to search for, say, the function call that you normally use to do that. And I'm not really remembering the procedure I used to break cmd.exe. But one of the nice things about this tool is that unlike IDA, it's fully read-write. Okay, whereas IDA is a read tool, generally. So if I have a copy of cmd.exe that's writable, and I find the code that's checking the registry, I can change it very quickly without having to use a hex editor. Another feature that this tool has and that I haven't found anywhere else. So I can go in here and say, change this opcode very easily. And it's even smart enough to ask me what version of the opcode I want, because some opcodes in Intel assembly are they're ambiguous. So, well, some of the mnemonics are ambiguous. And so I say I want that version of the opcode, and then I save it. And now CMD is probably going to crash when I file. So anyway, I just wanted you to know about this tool because I like it so much, and I wish more people knew about it. The website you can get it at is ht.sf.net. And HTE, it stands for something something editor. And that's Hotel Tango Echo .sourceforge. Thanks.
Hello, everybody. My name's Nick DiPetrello, and I pretty much wanted to come up here and just give a quick little 5-minute update on Kalia, something that nobody's talked about in any of the keynotes. I think it's really because, you know, basically with all this talk about privacy, encryption, and everything being monitored, well, who here knows what Kalia is? Yeah, okay, who here is a university student? Not as many as I hoped. That's okay, though. I'm sure you'll all want to hear about it anyway. Why am I qualified to even mention it? Well, I happen to work for an Internet 2 Gigapop. You know, we have many, many universities going through our large border routers and this and that, and I have my program blocking my logo, because I probably shouldn't be up here. But anyway, there was a meeting held about 3 months ago at MIT called the MIT Network Security Camp, and there was a large discussion about Kalia. And the basics about Kalia is the FBI just pretty much wants to require universities to allow them to do remote wiretaps. That's the short of it. There's a lot of stuff going on. I think it's TIA, it's a TIA sort of, like if you have a piece of equipment that's TIA certified in a certain number, I forget what it is, TIA like 5 something something or 4 something something, that's Kalia compliant equipment. And that allows you to do port intercepts. So you can just say, oh, well, this guy's Iranian. I want to go, copy all of his traffic without him knowing, without even the university knowing, perhaps. It's something that a lot of universities have to deal with because at first it was kind of ambiguous of what being Kalia compliant meant. So maybe, I don't know, maybe it would require that you have to upgrade your entire campus, and for a campus like MIT, for instance, that would cost like $1 billion because Cisco, costs a lot. So imagine having to go through your entire campus, no matter where you are, big school, small school, and having to upgrade all of your switches in all of your dorms to be Kalia compliant. Big problem. But never mind what the university's concerns are. The concerns really should be at the student level. This going along with the lines of the talks that were held earlier today. If you have something to hide, you're a terrorist. Well, obviously that's not the case, but that's kind of the impression you are given today. And as an employee of an Internet 2 ISP, and as a student myself, and as somebody who feels strongly about these subjects, if you have something to hide, you shouldn't have to feel like you are a criminal. But in this case, with Kalia coming around the corner, the deadline's approaching. If you're at a university, make sure to follow the advice of Simple Nomad and Corey and encrypt your traffic, and encrypt it all the time, not just some of the time. Because in reality, you won't know when your traffic's being monitored. And it's not necessarily going to be monitored at AT&T. It might be monitored in down the hall from your dorm, in your closet. And another thing, too, about Kalia, when Kalia was announced, the FCC was kind of testing the waters, I would say. They were basically like, okay, well, this is what we want to do. Okay, we're going to be quiet now. Everybody kind of got a little worried. They all met. They all said, well, what does Kalia compliant mean? And nobody really knows still. kind of just a big, like nobody knows. I don't even know, and I have to deal with it eventually. But if you are a university student, if you're not a university student, if you work at a university, you know what CALIA is, and you know that CALIA is coming around the corner, and it's just a big mess. So I just wanted to bring CALIA back into the spotlight. It wasn't mentioned before. And question?
And within the whole CSU, they just mandated a couple $1 billion for new switching equipment. We'll be using Cisco, and I wouldn't be surprised if it's in the firmware for CALIA compliance.
Yeah. Actually, yes. If you like the border routers of certain universities, there's a few universities just upgraded to like SOUP 720s. The SOUP 1440 from Cisco will be CALIA compliant, and now I'm starting to think that many companies like Juniper, Cisco, whatever, are going to just start making CALIA compliant just to sell to people at an absurd rate. You know, I forget what a 720 costs for a university. I think it costs like $25,000. I don't know what a 1440 is going to cost, but just keep it in mind when you're in your dorm and you're browsing for homework, porn, whatever. That's all. Thanks.
Con unless someone lost their job over a talk. So I want to thank everyone that had the marbles to come up here and talk for a few minutes. We're really glad that you were able to have a chance to speak your mind for a few seconds. And I think we're going to end this now and get ready for Dan Kaminsky, who is going to be coming up next. I thought he was in the back somewhere, but I'm sure everyone needs a few minutes to take a deep breath before Dan steps up on stage. So we'll be starting here in about another 8 minutes.